right. Our next speaker is Olivier Etienne. He works at Orange, and we have had quite a few talks here talking about testing on mobile. Olivier is going to focus about something completely different. How do you test on a set-top box? So,
yeah.
take it away.
Hi, everybody. So I'm Olivier Etienne. I work at Orange. Orange is a telecommunication operator that delivers mobile solution, internet access, and also TV. And today I want to share with you the experience we had in this context. So it's a kind of exotic context because we saw a lot of test automation on mobile phone, on server side, on classic context. You will see mine is a bit different. So I work in a team that aim to help other development teams. That is our function. So we work on any kind of transversal context problems, and test automation is one of them. So first, a bit of vocabulary. Anyone knows what is a STB? Okay, 3 people. STB stands for set-top box. Set-top box basically is a device that provides TV over the internet. And like a lot of devices that have very few resources, we have to reboot it. Because if we don't do that, you know the end of my sentence. So it will crash and you will have problem. But don't worry, if you don't do that, we do that for you. So when the STB goes into deep standby, the user didn't use it for 3 hours, we have systems that automatically reboot it, release all the memory, and put it in a low consumption mode. Okay. And also the aim of this device, of this kind of plastic box that you plug to your TV, is to deliver services. Services can be VOD, electronic program guide, some kind of tools to register TV, and any kind of tool that you can find on your TV. For a developer, STB, so the set-top box, is a kind of system like any other kind. There is a hardware layer that manages all the hardware, the CPU, the TNT tuner, video card, and so on. But there is a software layer with drivers, with the operating system. In our case, it's a very teeny Linux. It's a BusyBox, in fact. And on top of that, there is a browser. A web browser, classic web browser. And the last layer is the business layer, where we are developing our TV application. This business layer can be in different technology, native language with C++ and Qt. It can be web browser based, or in some really recent boxes, it can be Android. In our case, I'm going to talk about what we've done with a web browser based. Okay, and sometimes it can be a mix of different technology, and it's a big problem. Okay, next, what's the STB for Orange? Orange has so many customers. These customers are in different countries. So for Orange, STB is a device that is in the customer's living room, and there is some million of devices widespread all over different continents. There is also many different kind of STB, so many kind of device, and also many different countries. Our solution is deployed in France, Poland, Spain, and Senegal. But to do that, we just have one code to manage all these different configuration, hardware configuration, country configuration. So I think we can call that fragmentation, just like in the Android context. Yeah, as you can see, there is so many devices. This is a sample of the different kind of STB we have to deal with. So there is some kind of low cost, other premium boxes, or it can be a set-top box that manage satellite connection or DVB-T, any kind of context. So now the question is, how do you test your TV applications in this fragmented context? So let's get back 1 year and a half ago in the past. So we have our TV and the STB on one side. And you know what? To test that, we do just like you. We take a remote control. OK, we don't have beer, we don't have a sofa and Cheetos, not always. We take specification and test campaign, test suite, and all the description of what the product is supposed to do. And we take the remote control and we play on the different key in order to make the STB change the channel, enter the menu, etc. And when all of this is finished, we have to fill a report to say, OK, this version is certified. We can deliver this release to our QA team that is dedicated to end-to-end test. If we take a look at the development teams, we are working in agile mode, so we have sprints. Our sprints are generally divided in 4 weeks. We have 3 weeks of development and 1 week of test. During this week of test, 1 year ago, you put your keyboard and your mouse away, you take your remote control, and you just do that. You can imagine how the developer like that. And because of our context of the fragmentation, this is a really boring activity. And this is also something that is not very efficient because we have to spend a lot of time, 25% of our activity. And during this 25% of activity, we have to compile our application in different contexts, deploy it, set up the box, reset everything, and start our test for maybe 3 different countries. And we have to run the test on the things that we've done, on the new functionality, but we have also to test all the other functionality in order to be sure that we don't introduce some regression. So it's quite impossible to test everything. Even when we identify the things that may have changed, 1 week is not enough. And most of all, we are not confident in what have been tested because one developer can test in one way, one other one is a specialist of VOD or another context, and then he can do more accurate tests. And this is not the same person that tests the application from sprint to sprint. Because of that, all the non-regression campaigns are very expensive because we can test everything, so we have to focus really on what has changed, and it's difficult to identify. And this leads to a kind of fear to make any change. And as you can imagine, in an application that is 5-year-old, so kind of legacy code, if you're not able to do refactoring because you're not able to test, this is a kind of problem. And this affects your productivity and the quality of your product. So everybody was happy. And most of all, everybody agrees that we have to do something to solve this problem, and we need to automate all these activities. The automation objective was first to reduce the test campaign, because in 1 week, 1 week is not enough. We need maybe 2 weeks and maybe more. We have to do non-regression tests, functional tests, and most of all, we want to be confident in what we do. We know we have big refactoring to do in the code, and without anything to protect us against regression, we can do these things. And cherry on the cake, we have to use the target environment, because on STB, in our context, we didn't have any kind of emulator. So, in fact, we have a very teeny emulator, but we can use it in order to make tests. So we have to work directly on the target environment on the STB, so on this white box with a card inside that looks more or less to a Linux system, but with very few commands. And bonus option, if it can be low cost, it will be better because we can distribute the solution to any developer and spread it all over the group, on the different teams, QA teams, and so on, etc. And if it's easy to use, it will be better because we can involve other people and developers in these activities. To do that, so to replace the developer during the test phase, we try to hire the best. So we try to hire robots, but it's robots from the 90s, so they are a bit rusty. And I don't know if you remember how these kind of robots see our world. It's something like that. Something in red and white or green and black, low resolution. They have to do some kind of analysis to find what is exactly in this world that they see with a camera. And so we didn't recruit them. But you will see that we've done quite the same. We didn't recruit them, but we still want to have robots. This is a real image. There is a tool that works like that, just to test how the STB works with all the gyroscope. And this is based on Lego. But this works, and this helped a lot. So let's get back to our robots from the 90s. In fact, we've tried 3 kinds of tools. It's WITB, TACB engine, and STB testers. All these tools work quite the same. There is an infrared receiver and emitter that emulates the remote control. And there is some electronic device to do video capture and video analysis. So you plug it to your TV, and this does screenshots. And after that, after the screenshot, you have a lot of work. And that's the main problem of this solution. It's expensive for some of this solution. I think the WITB solution is 10,000 euros per equipment. So if you want to give one to each developer, it's a bit expensive. And the other problem is that create and use the test is also very expensive, because you have first phases to do is to teach your tool what to test. So you have to do screen capture of any of your UIs. And in the screen captures, you have to identify the things you want to test. And you have to say, OK, this is a button. OK, this is a text field. If it's a text field, you have to do text reconnection in order to capture the text inside. So very difficult. But it could be OK if there wasn't another problem, that is UI that change. We are developing TV application, and the UI may change in terms of style, the colors, the position of a widget, and all these 3 solutions are very sensitive to these changes. So it doesn't work. And if we get back to our 90s robots, we have systems that works quite the same. They do screenshots, and they try to find in the screenshot, in the image, what are the elements that they have to monitor. And the other thing that is a bit weird for a developer is that we are coding in HTML and JavaScript. We deploy that on the TV. And from the moment where we deploy that on the TV, we can just have screenshots. Other developers that does HTML and JavaScript have a lot of tools to test their applications, and they don't have to take a screenshot and analyze a JPEG image in order to automate their test. So this wasn't a good solution. We have a lot of problems with that. And we've tried to take a different approach. So in our context, we have 2 worlds. One world is the infrared world with remote control on one side and our set-top box and the TV on the other side. On the Linux system, on the set-top box, we don't have a lot of possibility to change the things, to add more tools, because this is a very teeny Linux with not a lot of functions. I think there is CD, ls, and maybe other commands, but not a lot. And in the other world, we have the tools that all the developer knows, Selenium, Mocha, Jasmine, any kind of tools that are used to test web pages. And between those two words, nothing. But I, developer, I hate to do repetitive tasks. I believe that machine should work for me, and I'm lazy. So I had to find a solution. And 2 years ago, there is a new system, a new small card. I don't know, maybe a lot of you know this card. This is called Raspberry Pi. Let's see how we use this Raspberry Pi. So we have our first world with infrared. And we decided to put a Raspberry Pi just in the middle. On this Raspberry Pi, we've had a card with an infrared receiver and an infrared blaster to allow this Raspberry Pi to talk in the infrared world. So our Raspberry Pi now knows how to read infrared and send infrared. But Raspberry Pi has also an Ethernet card. So Raspberry Pi can also understand HTTP requests. And now we have our system that know how to talk with the two worlds. So our Raspberry Pi will be used as the mediator or as the glue between the two worlds. And we've started to add new web service on this Raspberry Pi, such as send a key to simulate one key on the remote control, or send a sequence of keys in order to simulate user interactions that go on one channel, zap, zap, on the next one, and so on. And okay, and we also add in the responsibility to receive screen dumps. So he's able to receive screen description coming from the STB. So let's see what he does when we start from our little computer on the right of the screen. So this is the developer world. We start by sending an HTTP request to send an order to send a key. This HTTP request is received by the Raspberry Pi. He knows how to send an infrared signal, so he asks to send an infrared signal. This signal is sent to the STB that does all we ask, so change the channel. And we also add a small hack, in fact, on the business layer, on the application layer on the TV, because we are developers that work on that, so we have the ability to do that. And this small hack, 3 or 4 lines of JavaScript code, just do one thing. It retrieves the content of the main window and is able to send it back to the Raspberry Pi. The Raspberry Pi receives it and send it back to the caller. So now we have a synchronous call that does HTTP on one side, manage all that has been to manage for infrared, and send back a response to the HTTP request with the content of the screen. Yoo-hoo! So take a look, just a fast look at the Raspberry Pi and how did we customize it. So basically, Raspberry Pi is just this kind of card. So this is this size. And on this card, you have a Linux system. And on this Linux system, we've decided to add some other components, open source components. So we add an Apache, a PHP, and a Java engine. On the Raspberry Pi, we've developed a shield where we add an infrared receiver and an infrared blaster. And we also use some other libs like LIRC or P4G in order to manage the input-output with the electronic card. So now, when we send an infrared signal, we are able to catch it or to spy it with our Raspberry Pi. And so we are able to record a key or record a key sequence. And we are also able to emit infrared signals. OK, simple like that. So let's see what it does in real life. We have our Raspberry Pi. We send in an order through an HTTP interface. We ask him to start a key sequence. This key sequence is started, is received on the TV. We send back a dump, and this dump is received by the caller. In fact, the caller, the emitter of the HTTP request, was a simple web browser. And now we have on one side what is on the TV, and on the other side we'll try exactly the same content, but in our browser on the web developer computer. So that's a great news, because now we don't have just the PC of the developer on one side and the TV on the other side. And in some sense, my TV has become just a website. OK, the TV, the PC. We can start the first video. OK, so on this video, on the right side, there is my computer with a SSH connection on the Raspberry Pi. And on the left side, we have our Raspberry Pi, the STB. So here it is in spy mode. This means that I switch from channel. And you can see here the Raspberry Pi spy all the keys that have been pressed, and it stores that scenario. This means that now I recall the same scenario from a web browser, from my Mozilla, and this scenario is played on the TV. This is a bit dark, but on the left, this is my TV. So I can command my TV from my web browser. And at the end of the scenario, I receive, oops. OK, can we just show back the, no, we can't. OK, no problem. That was the video. OK, so we move from a specific and exotic context with a STB that is a kind of embedded device that has not a lot of functionality to something more standard, like a website. And that's a great news for developer, because when we go back to a standard world, we retrieve all the tools of this world. And if we take a look at what we've received in our browser, so this is my browser with a Firebug plugin. In fact, I don't have a screenshot. I don't have an image. I have the exact DOM content. So this is no more a screenshot. This is the real page. I got exactly the same things, the same structure, that the one that was used in my STB. So I can check the CSS. I can check any DOM element, its property, its content, etc. So I have the real DOM. And also good news, I will be able to use standard tools to send automatic tests and create a test suite. So we decide to use Selenium IDE. Selenium IDE manages test suites. Each test suite is composed of test case, classic. And in this test case, we have two kinds of activity. We can send order to the Raspberry Pi in order to send key or key sequence, or do any kind of stuff. We are able to reboot the box, to send a message to the Linux console, many things. And we have also the ability to do some assertions, so to verify, to check that what is displayed on the screen is what was expected. I think we have another video. Yep. So now let's replay the same thing from my browser. I launch my test suite that is running on my TV here. So the Raspberry plays exactly the same sequence that it has stored. And at the end of the sequence, it will send back a screenshot to Selenium. And you will see it's very fast. OK, everything is green. So now we make a big jump in the 21st century. We started from an infrared system. We added a Raspberry Pi in order to use him as an, through HTTP request. Now we've plugged Selenium on it. And in fact, we used not Selenium directly, but Selenium IDE. Why Selenium IDE? Because it is quite as good as Selenium, but you don't have to write code. It's much simpler. It has a kind of script language, and it's running in a Firefox plugin. So you don't have anything to install on your PC in order to run this kind of test. In fact, anyone doesn't have to install Eclipse or his favorite studio in order to write and run test. In fact, it was one of our secret objectives. We didn't want to be alone to write tests. We want to open the test world to non-developers. So with Selenium IDE, you just have to know XPath and some kind of assertions, a bit of scripting, and it's OK. Now, if we see the big picture of where we are, we still have our set-top box, our Raspberry Pi. But now, new actor, we have Jenkins. So next step, Jenkins, every night, it will check the test repository, because all of our test suite and test case are stored in our repository. He updates the Selenium context. He also retrieves all the code of our TV applications. He deploys this code on the STB, reboots them, reset the context, as for any embedded device, as we've seen this morning. And he runs the test suite. He recovers all the results. He creates for us all the reports, and is also able to push all of this in Quality Center. Quality Center is our repository for all our test suites. So we can create automatically our delivery status. And another thing we have added is a dashboard in order to follow all the status of all the test suites. Because now we have 6 different STB that we test every night. So this generates a lot of data, and we need to have a quick view on all the status of this test. And we are also able to generate this on demand. So about the results, when we start this experimentation, we just think that we will do something that simulates a telecommand, a remote control. And we've been far beyond, because as you've seen, the first step was just to provide an HTTP interface, but we added many functionality in order to get something that can be run inside Jenkins. We have added so many functions. So now we are able to reboot the STB, soft reboots by sending a reboot command in the Linux console, but we are also able to do electrical reboots. We've added some other components on the card, on the shield of the Raspberry Pi in order to control the power. We have, last week, we had more than 300 functional tests running every night. In fact, we have a lot of more tests, but we have some kind of filter in order to select only the test case that have not been flagged. And to give you an idea of what we've gained, 1 year ago, when we had to test all the functionality of the VOD TV application, This needs 5 working days. Now, with our test suite, these tests are made every night, and it costs 3 hours to Jenkins. So developers are happy now. And most of all, the team has gained a lot of confidence in this code. So we can start to do refactoring and changing our code. We have some things that ensure us that we didn't break everything. Okay. About the lesson we learn. In fact, there is some key points that lead to this success. First one is that we succeed because we have full control on all our data. We have a lot of mocks and stubs in order to simulate all the ecosystem. And we have the control on the data. This means that we can reset the data. We can predict what will be the data when we run the test, because when you test something on the live, the TV content, you have to be sure what is the current program. Another thing is we've identified that the test activity must be made very soon in the development cycle. Because if you don't do that, if you start with a legacy application, like it was in our case, you will have a lot of problems. In the code, it's quite obvious. If you want to test an HTML code, if you didn't put the ID on the different tags, it will be a bit more difficult. It's the case also in your architecture, but we've identified that also some other elements must be synced in a test way. It's the case for all our test plan. In fact, it's quite fun because when we begin to write automatic tests, we had to refactor our test plan because we have big test plans that say, okay, you do that, you do that, you do that, you do that, and you check a list of 20 or 50 items, and you can make a match, a direct match between this test plan and your automatic test suite. Another lesson we've learned is simple is better. Simple is better when you write automatic tests because what we didn't want is to debug tests. We prefer to have 20 simple tests more than one big. Because when it crashes, what we want to know is what is the functional item that doesn't work, and what is exactly in your UI. Where is the problem? You don't want to replay the test, add debug conditions to know why your test crashed. And last thing we've learned, everything can be automated. So there is a lot of things that are too difficult. We don't want to create a monster in order to test something that a human can test in 5 seconds. For instance, we have a lot of feedback with automatic test of the video quality or sound quality. There is a lot of tools that do that, but they don't do it well, and a human is much better to do that. And now, the question is, how do you test your TV application? We test like that, with Jenkins and a lot of Raspberry. We start with 10 Raspberry Pi, and we have a park of 40 Raspberry Pi, and this will certainly increase from week to week or month to month. Okay, it's finished. I think I've been a bit shorter than expected, but this gives us a lot of time for questions.
Thank you very much, Olivier. Do we have any questions on the moderator link? So while Alan sorts out the questions, anybody have a question in the audience?
So one of the questions from the moderator, you mentioned that the box will send back a screenshot after the test is run. Are there other means of verification?
Can you do it?
So after the test is run,
yeah.
it will send back a screenshot if it fails?
Yeah.
Is there another way
yeah,
that
in fact,
they get verified?
this is part of the things we've done more than just sending HTTP requests. When we started to put the test under Jenkins and to build every night, we have a big amount of things to analyze. And we realized that we need some more information than just an assertion that say, okay, that fails. Because sometimes what fails, what the STB that didn't do is reboot fast, so it's completely frozen. So now, when there is a crash, we keep the screenshot of the screen, and we also catch all the logs of the STB, and we associate that to the test in order to have a easier investigation.
Any other questions? All right. Thank you so much.